So hello once again, welcome back to our YouTube channel. Today we are continuing with the canal design, but mainly focusing on the most economical section or the most efficient section, the best hydraulic section, and so on. So why do we call it just the most economical section? Why do we call it like that? Or the most economical section, the best hydraulic section, or the hydraulic efficient section. If you want, you can hydraulically efficient section or the hydraulic efficient section. If you want, you can remove this hydraulic efficient section, whatever you like. So why do we call it like that? So first of all, to better understand the situation, better to first of all focus on what we call weighted perimeter and the other parameters related to the canal. If you have a canal like this with a given water depth, let's call it Y. You can call it Y or H. This is the water depth. Assume that our channel, this is a rectangular channel, assume that the width, the bottom width is B. Let's call it the bottom width. So, you already know that to get the weighted perimeter, what is the meaning of weighted perimeter? The weighted perimeter is just the perimeter of the channel in contact with water. If you move from here, you measure this distance, plus this distance, which is B, and plus this distance. It's meaning what? If you go through the channel, so this is the one called weighted perimeter. So this is Y as well, and this is B. So meaning what? The weighted perimeter in this case, P, weighted perimeter is equal to 2Y. This Y plus this Y, 2Y plus B. This side plus this side plus this side. You see, we have now 3 sides. We have added 3 sides. So that is what we call weighted perimeter. Weighted perimeter. Weighted perimeter. So this parameter plays an important role when we are designing canal, but mainly when we want to get the most economical section. Remember that when we are using Manning to calculate the discharge of the flow rate, 1 over n times cross section times the R, the hydraulic radius, times the slope of the channel. So meaning what? The roughness depends on the material which construct our channel. If it is a concrete, it has a given value. If it is maybe unlined channel, it has different roughness. If it is brick masonry or stone masonry, they have different roughness. So that will depend on the type of material lining the channel. And the cross-section depends on the dimensions, our dimensions. You have your bottom width and you have your water depth. It's a matter of multiplying. In this case, in our case, the area can be equal to Y, the water depth, times B, because it is a rectangular channel. In this case, this is what we call hydraulic radius. You already know it. Radius. This is the hydraulic radius. How do we calculate it? The hydraulic radius is a matter of taking the area, this area over what? Over P, weighted perimeter. In this case, you can take, in this case, it's a matter of taking Y times P over 2Y plus B in this case. So this is how we can calculate the hydraulic radius. So you see, the higher this value, the higher this value, the smaller will become this. So if you get a small value here, you will get a high value here. So, and the discharge will be passed through your channel will be maximum. So what we want when we are designing what we call the most economical section, the base hydraulic section or the hydraulic efficient section. We want to pass the maximum flow through our channel with smaller water perimeter, which means where we have the smallest perimeter, that channel will be selected compared to other channel which has somehow a bit higher value, a big number or a high number of water perimeter. So if you have let's say two different channels which can carry the same, which one having maybe water perimeter of 5 meters, and another channel may be having P maybe 4 meters. Other conditions maybe are the same, something like that. So to get the best hydraulic section, we better choose this one because the water perimeter is smaller. When the water perimeter is smaller, it means that we will get a higher value of hydraulic radius, meaning that the higher the value of the hydraulic radius becomes, the higher the discharge and the economic we are, because we have a small perimeter to be lined, to be excavated, something like that. So then we will be more economic than someone who has a bit higher value. So the same, this is the bottom slope of the channel, so it will depend. So, and then you multiply, you get your discharge. That's where I wanted to reach to better understand the situation. So, so coming back to our definitions, we can say that coming back to our definitions, we can say that in order to have the most economical channel, we should be having minimum construction cost. So the most economical section is of a channel is a channel with minimum construction cost. When we say minimum construction, we mean what? We mean the excavation cost, and the lining cost should be minimum. Smaller, lower, something like that. So when we are talking about the most economical section, we mean what? So when we are talking about the most economical section, we mean that the cost of construction of that canal. When we mean the cost of construction, we mean the excavation, the cost of excavating, the cost of lining. What is the meaning of lining? Lining is just providing a material to our canal for minimizing the water losses, I mean maybe the seepage is minimized, water lost through the seepage. When the water leave the canal through the nearby soil, you are losing your water. So when you provide, maybe you construct your canal with concrete or stone masonry or brick masonry, you are minimizing the losses. Not only that, but when you are also lining a canal, you are also doing what? Preventing erosion of canal banks, and even the bottom. So when you have a channel which is well lined, these banks are not eroded, or they are not eroded easily. So that is the meaning of the most economical section. The most economical section of a canal is the section with minimum cost of construction, with minimum cost of lining, minimum cost of excavation. So what are the conditions now? There are different conditions in order to get the minimum cost of construction. So what is the condition? So the condition is what? Let us see. But before seeing the condition, we can say also that when we talk about the best hydraulic section or the hydraulic efficient section, it means that the canal, the channel is a section, is just a section of a canal which can pass maximum discharge, which can pass maximum flow. Maximum flow. To pass the maximum flow, we have seen that to pass the maximum flow, the weighted perimeter should be minimum weighted perimeter. The weighted perimeter should be minimum in order to have a maximum flow. So that's the meaning. So to summarize, we can say that the most economical section is a section of a canal which can cost less, or which with minimum cost of construction, cost of lining, cost of excavation are minimum. But also that section, when it is called the best hydraulic section, they are used in simultaneously in different ways, but they mean more or less the same. So that section is costing less, but also is carrying maximum discharge because the weighted perimeter is minimum. So what are now the condition of having the minimum? Of having the minimum construction cost. So let's start from the most economical rectangular section. Assume that we want to construct a rectangular section, but we want the best dimensions, which will cost us less. So first of all, if you have a rectangular section with the bottom width of called B and the weighted perimeter, the water depth Y. So the condition of having the most economical section, condition in order to be minimum, the derivative of weighted perimeter with respect to water depth should be equal to 0. That is the condition. The derivative or the differentiation of just the weighted perimeter with respect to water depth should be equal to 0. So that's why we should first of all put P. We should put P in a function of Y. So what is P here? So we have already Y, 2Y plus B. And on the other side, we already know that the area is equal to BY. B times Y, meaning that B, if you replace B, is equal to area over Y. So this is 1, this is 2. So once you replace 2 in 1, so let's put 2 in 1. In 1, we get what? P will be equal to 2Y plus what? Plus A over Y. A over Y. So if you do the derivative and equalize it to with 0, derivative of this, putting P in this, we get 2Y plus A over Y with respect to what? To y. Then if you derive, what do we get? If we make the derivative, what do we get? So if we make the derivative immediately, here we remain with 2, here we remain with a over y squared, which is equal to 0. So if you change members, so we will get a equal to 2y squared. So we already have the area is equal to 2 times water depth squared. So for the most economical rectangular channel, that is 1. So let us now replace that in the other formulas to get the real value. So let us call this is, let's call it maybe 3. If you replace it 3 into 2, 3 in 2, what do we get? 3 into this, in this we get b equal to 2y squared over y. To simplify, remain b will be equal to 2y. b is equal to 2y, or y is equal to b over 2. This is an important thing when it comes to the most economical section. So by continuing, we already see that we have our water depth, this relation, and the area. So we can replace here, b can be replaced by this. So if you want, you can say that p in this case will be equal to 2y plus b. What is b? b is equal to 2y, meaning that b will be equal to 4y. So what will be the hydraulic radius? Hydraulic radius is equal to area over p. So when we have the most economical rectangular section, area becomes 2y squared. 2y squared over p, which is 4y. So simplifying, and this remain with y over 2. So these are important things to note, mainly this one. This is important, and this is important, and this as well. These are important things when it comes to the most economical section. So these are things should be taken by heart. So you can summarize saying that when we have the most economical rectangular section, area is equal to 2y squared. Y is the water depth. Y is the water depth, and the bottom width is the double of water depth, this one, and the hydraulic radius is y over 2. These are important formula when it comes to most economical rectangular section. Let's see through an example. So when you want to design the most economical rectangular section, what do? You have to take to have this in your mind, that the area is equal to 2 times y squared, b is equal to 2 times y, and the r is equal to y over 2. This and this, the hydraulic radius and the water, the cross-section of the channel, the cross-section of the flow are just expressed in the formula of Manning. Meaning what? If you have Manning like this, 1 over n, area r 2 over 3, square root of the slope. What do you do? Once you are asked to design the most economical rectangular section, what do you do? First of all, you have to replace here by these things. Meaning what? Q is equal to 1 over n. Area, you replace it with 2y squared, and the r is replaced by y over 2 power 2 thirds, square root of slope. Now you have your discharge. you have a discharge, you have your roughness, and you have your slope. You have these three things. Now you are asking yourself what would be the dimensions of your channel. It will become easy because you replace everything here, then you calculate your y. Once you get your y, it becomes easy to replace it in here now to get the bottom width. And once you have your bottom width, you are almost done. If you have a rectangular channel and you have your bottom width, B is already calculated because you have got y. B, once it is known, it is easy to know the excavation and the depth of your channel, because the remaining thing here is the freeboard. The freeboard will depend on the recommendations provided by different institutions, but you can use the United States Bureau for Reclamation recommendation, something like that. So this becomes easy. So let's just throw an example. So let's continue with the most economical trapezoidal section. Assume that we want to construct a trapezoidal section of a canal, and we are wondering what is the most economical section when we want to construct a trapezoidal channel. So first of all, you needed to have your parameters. We have our water depth here. We have the bottom width, and remember that the top width here, from here to here, the top width is called capital B, and if you have your side slope, the side slope, assume that I have maybe 1 over m or z. The side slope, to better understand the side slope, is how is this side is inclined. Is it inclined like this? Is it inclined like this? Or is it inclined like this? To better understand how it is inclined, or the angle between this angle. So this angle is the same as this angle. Let's call it theta. Let's call it theta. So how is this side inclined? So to better understand it, that's why we provide the side slope. The side slope shows the ratio, is like a ratio. The ratio between these distances. Between if you wanted to get this angle, you can take the horizontal over the vertical. Between the horizontal and the vertical. The horizontal and the vertical. If you want to get this angle, assume this is y, maybe. This is y. This is y. And this is x. From here to here, it is x. From here to here, this is x. So if you want, there is a quick relation. If you want, so the side slope in this case, you can say that tan theta using this triangle, tan theta is equal to y, is equal to, x over y. This over this. The same as if you use this small triangle, tan theta, if you use this small triangle, tan theta in that case is equal to m over 1. M over 1. M is a number, assume it is a number. So which is equal to m. So meaning what? If one is 1 and this is 2, you will say that maybe 1 is equal to 2. 1 is equal to 2. Because this is tan theta, this is also tan theta, meaning that x over y is equal to m. So x is equal to my. So meaning that this is my, this is my. Meaning that if you have a number here and here you have 1, it's a matter of taking this number times the water depth to get this distance. This is what it means. What else? This inclined side is also needed. This inclined side, let's call it L, is also needed because we need it when we calculated the weighted perimeter. In this case, the weighted perimeter, if you want, the weighted perimeter can be equal to 2L plus B. This is L, from here to here is L. This is also L, from here to here. 2L plus B. So how can we get L in a function of side slope? So we have our X and we have our Y. We can say that L is equal to square root of X squared plus Y squared, meaning that L is equal to X, replacing this is X, meaning that my squared plus Y squared. This is the square root. This is the square root, meaning that L is equal to what? Square, this is square. You can say maybe it is Y square root of M square plus 1, if you want like this. So this is this side. So what else? So we can say that this is X, which is equal to My. This is also equal to My. So what can we say about P? If you want, you can replace this in this. Let's call it 1, let's call it 2. So 2 in 1, what do we get? 2 in 1, what do we get? You get P equal to 2 times R times this plus B. So this in this here plus B. So that is the weighted perimeter in a function of what? In a function of side slope. So what else? The cross section. If you want the cross section in a function of side slope, already it is equal to, no, before calculating this, remember that B, the great base, is equal to summation of these things, 2x plus B, because from here to here this is also B. So the same B can be equal to 2x, meaning 2my. X is equal to my plus B. So B in a function of side slope. This is how we can. B in a function of side slope, P in a function of side slope, R in function of side slope. So the area is equal to B plus B times Y over 2. Putting everything here, so what do we get? Area is equal to B, 2my plus B, 2my plus B plus this small b times Y over 2. Meaning what? This is 2b, 2 will be cancelled with this one, we will remain with 2my plus b times Y. So this is how we can write the cross section in a function of side slope. So now what are the formulas? What are the formulas when we have the most economical trapezoidal channel? So first we have to make the derivative of the weighted perimeter. The derivative of the weighted perimeter. So the derivative of the weighted perimeter. So first of all, the weighted perimeter is equal to that, but B, if you want, you can replace B by maybe let us see how can we get B in that section. In this B, we already know that A is equal to my plus B times y. So if you replace everything, so B becomes A over y minus my. So this can be replaced in this formula. Then we get P is equal to 2y square root m square plus 1 plus B. B is this one, A over y minus my. So now the condition. So the condition, the derivative of P in a function of y should be equal to 0, meaning that it is the derivative of all these things. 2y square root m square plus 1 plus a over y minus my with respect to this should be equal to 0. So let us make the derivative. So here we have tried to show a summary. This is a summary. So these cases mainly, these are two important things. First of all, so after all demonstrations, without going through the demonstration, because if you want to see full demonstration of the derivative and so on, watch the video in the description or using this link to better understand how everything has been derived. This is the video is a summary of what has been demonstrated. So through going through all the demonstration, it is now clear that generally in order to have the most economical trapezoidal section, if you want to get a most economical trapezoidal section, these are two important conditions. This width, the top width, let's call it maybe top width. The top width of your trapezoidal channel is equal to the double of one of the sloped side. So B is equal to 2 times L, the sloped side. Or in other words, one of the sloped side is equal to the half of the top width of your trapezoidal channel. Another important condition, this is the same like what we have seen in the rectangular channel. The hydraulic radius is also the half of the water depth. These are major conditions. So these are common to all type of most economical trapezoidal section. Whatever side slope, these remain the same. These two. But now let's go to these remaining things. Depending on these are the conditions for the most economical trapezoidal section. If the side slope has not been recommended in other way. So first of all, in order to have the most economical trapezoidal channel, the side slope, to get the most economical side slope or slope or angle, this angle, so you have to make the derivative of P with respect now to M of the same like what we did previously when we wanted to know the other relation. So when you continue, the other relation provided this, indicated that B, this is a B, the top width is equal to the double of the sloped side. This one is the same as this. This is the same as this. This is the same as this. So when you derive previously, when we have derived the perimeter with respect to water depth and equalize it with 0, we end up with this relation. It indicated that if you do it yourself, you will find that the top width of your trapezoidal channel is the double of one of the sloped sides. And now to get the most economical side slope, or this angle which is most economical, you have to take the same expression and make the differentiation or the derivative with respect to the side slope. So after, when you continue this way, you will end up with m equal to 1 over square root of 3, and calculate the tan of that, this number. Remember that we have seen that tan theta is equal to m. If you calculate this, tan theta is equal to m over 1, which is m. So if tan theta is equal to m, it means that tan theta is equal to 1 over square root of 3. If you continue, we'll get this angle. Meaning what? If you have a side slope, of, let's say, put here 1 over square root of 3, if you move like that, you will end up having an angle of 30. This means that for the most economical trapezoidal channel, the angle here should be 30, making it that the sloped side is making it with the vertical. Or in other words, this remaining, this is 60. 60 plus 30 is 90. So this is common when we have a side slope of this. So replacing, now if you have m equal to this, if you replace this relation here and here, you remain with b equal to this. B will be equal to this, and if you put that relation in here as well, this is the general expression expressing the area in terms of side slope. So if you replace your b here and your m here, you end up with this relation. So if you replace your b here and your m here, you end up with this weighted perimeter. So generally that is how we will compute. Meaning what? If you want, you can also, say that m here, this is the same as 2 over square root of 3, the same as 1.15y. It is the same. This is the same as this, and the area 3 over square root of 3, the same as 1.73 y squared, and this p 6 over square root of 3 is the same as 3.46 y. What does it mean? If you have a question, we will have maybe an example. In a few minutes, we will have an example to better understand how we can calculate the best dimension of the most economical trapezoidal channel. If you have your Manning equation, what do you do? In your Manning equation, what do you do? If you are designing the most economical trapezoidal channel, what do we do? You replace here with y over 2, this, and here area can be replaced by 1.73 y squared. This one can be replaced down, and then compute, and you get your water depths. Once you have your discharge, you have your roughness, and you have your slope. Computing everything, you will get your water depth. Once you have your water depth, it is easy to replace the water depth in here to get your bottom width. And once you have your bottom width, you can easily draw your channel, trapezoidal, most economical trapezoidal channel. And then you can also get your B, the top width, you can also get it. And for the freeboard, they are recommended by different institutions, but most known is the United States Bureau of Reclamation, which recommend different freeboards, like 0.75 for discharge ranging from 1 something like that cubic meter, so and so on. There are different recommended freeboards. So you can watch, for more detail, you can watch the other video on the full description of the most economical channels. So now, if the side slope is different from this, let's take an example. If you have a side slope which is different from 1/3, if you have another proposed side slope, you assume that maybe you don't have these are only valid when you have a side slope of this. But if you have another side slope, if you have maybe a side slope, if the side slope m is different from 1/√3, if it is different from 1/√3, because depending on the terrain condition or the client can propose another side slope, still want it to be more economical. If he has proposed, let's say maybe m equal to 3/2, or if he wished to have maybe a channel like this, here 2 and here 3. In this case, tan theta, which is called, in this case, if you want, you can say that m is equal to, simplifying, you can say that m is equal to 3/2, because tan theta is equal to m and is equal to this over this. So m now is different from 1/√3. So how do we proceed? Now b, you have to compute b, so which means m, now you have to bring m and put it here to get the new expression, and put m here, the new m, and get the new expression. Maybe you will get a b which is maybe somehow maybe 2 point something y, and after getting b, you can replace its expression here as well, and the m here as well. So that new expression of area is the one that you will put in Manning. R remains like this, doesn't change. For the most trapezoidal channel, the R is equal to y/2. It doesn't change. The same, the top width is the double of R. It doesn't change. The condition remains like this. But for the values the value, the area, P, the B, and so on, all these, the cross-section area, the weighted perimeter, and the bottom width, all these things depends on side slope, depends on side slope m. So if m changes, the expression for this also change. So the expression, that's why when you have m, if you have a given side slope, first of all you have to replace that side slope in this relation. Once you replace it in this relation here and here, you get the new expression of the bottom width. After getting the expression for bottom width, you can replace that bottom width expression here and the new side slope here to get the expression for the area. That expression for area is the one that is put in the Manning. So here the expression will depends on this. The expression you have in function of water depth is put here, and here you put y over 2, something like that. So let us understand through examples to better understand these calculation and these expressions.